In this video, we examine some ideas from the psychology of learning. The first thing I want to explore is the familiar phenomenon of forgetting. Over time, students tend to forget what they recently learned. A forgetting curve shows the fraction of students who retain a new concept if it is not reinforced. In this example, approximately 40% of students who are introduced to a new fact will retain that fact for one day without reinforcement. Facts that are easier to remember will have a flatter forgetting curve. In this graph, 60% of the students are able to hold on to a memory for 24 hours. Hermann Ebbinghaus was the first person to study forgetting curves scientifically. In the 1890s, he published results which showed that retention tends to fall off exponentially with time. His most celebrated result, however, has to do with the effects of reinforcement on learning. Ebbinghaus demonstrated that with each subsequent presentation of a fact, the forgetting curve becomes flatter, which means that students are able to retain information longer. Repetition is the key to retention. The shape of an exponential curve is determined by the parameter s, which is called the mean lifetime, because it corresponds to the average amount of time that a memory will be retained without any reinforcement. Flatter curves have a larger mean lifetime. Some authors call this parameter the strength of memory. Plotting the strength of memory over time, we see that it makes discrete jumps with each subsequent reinforcement event. The amount by which memory is strengthened depends on the amount of time that has elapsed since the last event. If the temporal spacing between events is too small, the brain doesn't have time to assimilate the new information, and the second event doesn't strengthen the memory at all. Conversely, if the temporal spacing is too large, the benefits from the previous reinforcement are lost, and again, the second event produces little strengthening of memory. Between these two extremes, there is a temporal spacing which maximizes the amount of learning that occurs. At this point, memory is strengthened the most. This relationship between elapsed time and the strengthening of memory is known as the spacing effect.